the event of an emergency. Now, I'm going to hand over shortly to Annick Wastio from the Belgian Research Institute VITO to welcome the session and also introduce the concept of active energy performance contracting, which many of you will be familiar with. Subsequently, we have Carlos Sanchez Rivero from the European Commission to tell us about the legislative framework at the EU level for this important topic. We have Valeria Palladino joining online from the Italian National Energy Agency to look at some of the regulatory issues in more detail, including barriers in some key countries. Jesse Glicker from the Buildings Performance Institute Europe will be following up with some policy recommendations, with the BPIE's work on this being quite extensive. Then we'll have time for some Q&A. The speakers will all make the presentations here at this lovely podium and then have a seat here on stage so the audience can ask some questions, and we have some online questions hopefully as well. Then in the afternoon, Lieven van Stralen from Energy Invest will give us some insights both on the AAPC concept as well as a bit later on the Belgian pilot from the project. Claire Harvey from the Portuguese utility will discuss the Portuguese pilot in more detail, and we'll have a chance also to hear from Claire and Lieven both in the panel discussion at the end of the morning. The last presentation itself is from Volker Dragon from Siemens and EU ESCO, looking at this topic from a go-to-market from a sales perspective. And finally, we have a really great panel lined up, which I'm looking forward to. As I mentioned, we've got Lieven and Claire. We also have Chris Kaerts from VITO, Gregory Tilte from Equans, and Volker and and also Sofia Tavares joining online from EDP, the Portuguese utility. Annick will provide some conclusions for us at the end of the day, and then we'll have a chance to wrap up and have a nice networking lunch afterwards. So without further ado, I'd like to welcome Annick to the stage, please, to start us off, and wish you all a very good conference. Thank you.
Is the microphone working? Super, thank you. Good morning and welcome everybody. Happy to see you here in real life, and also welcome to the people viewing us online. I'm very happy to present you the work that we have been doing the past 3 years. You will see that when we started this project, actually it was needed and it was actual, and it is needed and it still is very valuable. So that's what I'd like to share with you here. Why did we start the project? Of course, we have a very important challenge. We had it when we started the project, but it's still there today with climate. Climate change. You see that all these huge papers, The Economist, BBC, European Commission, even NASA, they are all still telling us we have to do something. We are emitting way too much greenhouse gases. At the moment, we have of Russian gas. Of course, we want to punish the Russians because they invade Ukraine. We want to get rid of their gas, but honestly, we want to get rid of all the gas. It doesn't make sense for us that we take the Russian gas and then take shale gas from America. It wouldn't help us here. So this is like the message I want to share with you here. If we want to do something for the climate, we have to work on these carbon emissions. And this means, and that is what we will show you, go for electrification from renewable energy sources and get rid of the gas. Another important thing for AmBIENCE is that we focus on buildings. Why do we focus on buildings? Because when we look to the CO2 emissions that are emitted per year, about 40% is linked to buildings. That's huge. It can be the materials that are needed to build the buildings, or the process to build the buildings, or just the operation of the buildings. You're in a building, you want to have it heated, cooled. All these things require energy, and this is linked to huge emissions. And this is why in AmBIENCE we wanted to focus to reduce the carbon emissions from buildings. You see here the EPC classes, the European building stock. And what you see here is quite dramatic. We see that in Europe, a lot of buildings are actually, they're not good. They are not well insulated. They are taking tons of energy the house or to cool the house when it's warm. And this is why we have to work on these buildings. Of course, we don't do this alone. There are quite a lot of initiatives. We have the EPB directive. We have smart readiness indicator. We have now the Fit for 55. A lot of activities, a lot of actions are taken. And AmBIENCe, of course, is only one of them. But I think that AmBIENCe makes a difference. Why? Because you look to these EPB classes, you see that it's not easy. It will require a lot of money, a lot of budgets. It's too expensive, basically, to have all these building stock renovated to such a way that we don't need energy anymore. And that's, again, where AmBIENCe comes in and where we say, if we can do renovation to a certain level that allow us to do electrification, and then with these renewable energy sources, then we're doing a hell of a job with regard to reducing the carbon emissions. And this is where I come to what we wanted to do with AmBIENCe. So we want to reduce the building emissions in the European Union, of course, by electrification, and this in combination with why, ooh, sorry, I go back here. Voilà. Make thing or hot tap water, electrification is often way much more efficient than to choose for electrification, especially if we know that the carbon intensity of you'll have more windmills, more PV, global of electricity will continue to drop. Today, you do electrify your building, additional costs. In the next can decrease. Okay, this better? If you have these renewable energy sources, yeah, they are only there when the sun is shining. Your PV panels are like helping you out. Same for wind. So you have this fluctuation during the day, during the seasons. And that's why it's very important that we are somehow flexible and that we use the electricity at a moment when it's available from a carbon-free or an emission-free source. And this is, of course, also something that we will tackle here with regard to in AmBIENCe. And then it comes to the mission is to improve the economic attractiveness of building emission reduction measures by combining the energy efficiency with electrification and active control. Now, what is AmBIENCe? AmBIENCe stands for Actively Managed Buildings with Energy Performance Contracting. So you hear energy performance contracting. That's already existing for many years. What we do in AmBIENCe is we extend the classic traditional EPC with demand response. And this way, this allows us to include the flexibility that is available from active buildings. This active building EPC is not just usable for office buildings, but for many more buildings, also residential buildings, as Lieven will highlight out in the Belgian pilots. Of course, if we want to measure the flexibility, we need some tools, we need some materials to figure out and to forecast the demand response value streams and the value of flexibility. Both in the contractual phase, but also in the operational phase, we need to monitor that. And this we have all done in AmBIENCe, and we have validated the concept, the methodology, the tool in 2 pilots, which will be explained later on today. Let me go to. So this is the consortium, for those of you that didn't want to check yet on the website. 8 partners from 4 countries, all working
for the last 3 years on AmBIENCE. So the project started in June 2019, and it ends by the end of the month. So it's a quite challenging month for us. We're happy to have you here, but we hope that afterwards you also check on the website, because we will have quite some new findings the last few weeks of the project, so the next weeks to come. You see here the 8 partners. So we have one partner from Italy, Enea, who's unfortunately not here today, but you will, not in physics, you will hear them online. We have 2 partners from Spain, 2 research partners, SAIT and Techniker. 2 partners from Portugal, Inestec as a research institute, and then EDP, both research and commercial entity. And then we have 3 partners from Belgium, BPIE, who is organizing this fantastic conference here today. Then Vito, where I'm from, Flemish Institute for Technological Research, and then Energinvest, who's our business partner from Belgium. Forgot to say, but we got 2 million from the European Commission for the Horizon 2020 project, which we are very grateful for, and which you'll see that we have used in a good way. Active building EPC, because that's actually why you're here, to figure out what is now the active building energy performance contracting. It's something new. You can see here we are at the cross line of 2 things that were already existing. We had demand response, we have EPC, and now we're actually bringing them together. That's not so evident, because these are 2 different worlds, with 2 different methodologies, 2 different actors. The business models are different, so we had to combine them in a good way. And it worked, because we find out that if we have demand response included in EPCs, that we actually can improve the business case. And on the other hand, we also know that demand response can support EPC contracts. And we put the 2 together, and on the intersection we have the active building energy performance contract. Yeah, this is like the official definition, which you can also find deliverable. So the active building EPC concept is an enhanced, modular, and performance-based delivery and financing mechanism for energetic renovation and optimization of both existing and new buildings. Oopla. Thank you. Tapping into all passive and active energy and cost-saving measures, while leveraging a comprehensive set of technical, operational, usage, behavioral, and dynamic energy or CO2 pricing parameters. Wow! I would say, read it. We have a deliverable, and there you have every tiny part nicely explained. Basically, I would say we have the active building energy performance contract. It's an extended and enhancement of the basic EPC concept. And what is important is that we focus on electrification, also for local heat supply, and that we add the active control measures. So this is again the concept. I don't know if I have a pointer, but on the left you see the traditional EPC. So you have the ESCO and the client. The ESCO provides energy efficiency measures in the building of the client. He provides a performance contract to do that. Sometimes he also provides a loan to the client, and then the client saves money because they have the energy efficiency measures, and with the savings they can pay the ESCO for all their services. And that's basically what happens in the traditional EPC. Some of these things you also see in the active building EPC, but you see that there are additional features in yellow, and you see the demand response. So again, here you have the ESCO who's providing energy efficiency measures for the client, but in addition, also flexibility measures, and it can do that for more building types and for clusters of buildings. So it's an extension of the classic traditional EPC. You see here that there is this demand response, so this is an additional thing that is in the active building EPC. The client, again, saves money, saves energy, but also money. And with that money, he can pay the ESCO for the budget, for the services. What you see, again, here is that there are these 3 additional features. We have the extension of the EPC contracts with flexibility through demand response services. The classic EPC contract can be enlarged to much more different building types, and also to clusters of buildings, which is, when you look to local energy communities, also, of course, something that we have to take into account. Oh, now I went too fast. So it's very nice, of course, to have a new concept, but if you want to do that in practice, you need some tools, you need some material to work with, and that's why AmBIENCE comes in. Now, AmBIENCE is the Active Building Energy Performance Modeling Platform. It's a simulation tool that is based on a model predictive control approach, and it is helping you to calculate and guarantee the operational cost savings and performance KPIs. It's also helping you to calculate the financial viability of the renovation, and in the operational phase, it's helping you to update the performance guarantees through the operational phase. Important here is that we have multiple stakeholders, multiple renovations, multiple demand response, cash flows and control strategies, and they all can be taken into account in this AmBIENCE tool. So for example, for stakeholders, you can look at from the point of view of a landlord, but also of a tenant, or even from a third-party financing investor. They can use this tool to figure out what's in there for me and how can it work for me. You see also that it works for multiple renovations, of course. Some people only want to do some insulation measures, but some others want to go all the way. They also want to do electrification for heating, or electrification for hot tap water. Some want to have to install PV or other renewable energy sources. An electric car. Today in Belgium we will need electric cars in the next few years, so that means that every house, every building should have possibilities to link to electric cars. So all these different combinations can be calculated with this AmBIENCE tool. You also see that we have different demand response control strategies. The most simple is, of course, on-off. But you could also say, I want to do smart control because I want to minimize my energy consumption. Somebody else says, no, I have PV. I want to maximize my self-consumption. Another one says, I don't care. I just want to minimize my cost. Or somebody who's really green, I would say, I want to minimize my emissions. So you can have plenty of ideas, plenty of targets that you can use to calculate here the possibilities with this AmBIENCE tool. You also have there at the end the demand response cash flows. It depends on your prices and tarifications. You have fixed prices, you have capacity tariffs. Do you have peak shaving, peak prices, all these kind of things? They all matter if you want to check if you can have a viable business case in active building EPC contracting. And this basically was my story. I can talk a lot about this, but I hope that I have teased you a bit about the interesting world of active building EPC, and that, you all are a bit challenged and hopefully have a nice meeting today. Thank you.
Is this microphone still seems to work? Thank you very much, Aniek, and apologies, I didn't actually mention that Aniek is the project coordinator for VITO. And she also has a bioscience engineering degree and a PhD in medicine from Catholic University Leuven. So very good to have you here with us today to share your knowledge. My pleasure now to introduce Carlos Sanchez Rivera from the European Commission. Aniek had given us the wider context of climate change and the reason why this topic is very important. Very much looking forward to another presentation now, also looking at the important context that we're in, of course, with the Ukraine crisis, and also the framing of this within the European regulatory dimension. So please, Carlos, the floor is yours.
Thank you, Armin. And good morning to everyone. It is really my pleasure to be here today with all of you in the final conference of AmBIENCE. So sound is working well, right? Good. Excellent. So I would like to, yeah, it's working well. So I would like to start with a short policy update on energy efficiency and also on the latest policy developments in the EU concerning energy. As you all know, Europe is facing a double energy crisis. On the one hand, an energy prices crisis. So together in parallel with the economic recovery post-COVID, the EU is experiencing a period of sustained high energy prices across the board. On top of that, Russia's unprecedented and unprovoked military aggression on Ukraine has raised also security of supply concerns. So in this drastic scenario, is strengthening energy efficiency is probably more important than ever before. And in fact, energy efficiency is recognized as a key element to enhance the independence, the resilience, the autonomy, but also very important as well, the competitiveness of the EU energy system and its economy. So the dual energy crisis will require a much faster phase out of fossil fuels compared to the scenario where we were some months ago. On the positive side, if there is a positive side in all that, I would say that the business case for energy efficiency is stronger than before, and this is because of the impact that the high energy crisis and the need to become independent from external fossil fuel supplies impose. The higher energy savings value, because of that, payback times for energy efficiency are significantly shortened, and therefore the interest for energy efficiency is increasing. So with that context, we do not have other alternative than to accelerate our ambition when it comes to energy efficiency policy. So we need to boost the investments. So in this regard, as you know, the European Commission adopted in last July 2021, as part of the Fit for 55 package, a proposal for a recast of the energy efficiency directive. And this really constitutes a very good basis to further energy efficiency ambitions. As part of the interinstitutional negotiations of the energy efficiency directive, I would also say that the European Parliament has already proposed to increase the energy efficiency 2030 target and its ambitions. So what it is clear is that in order to achieve the Fit for 55 objectives and now the REPowerEU objectives, the REPowerEU is the Commission response to the Ukrainian crisis when it comes to energy. Energy efficiency objectives are more important than ever before. So we need to reinforce financing schemes. We need to promote even further the access to finance and the leveraging of private investments. In all that, energy efficiency, energy performance contracting, and innovative financing schemes have a very important role to play. And indeed, and we'll try to focus now a bit on the concept of energy performance contracting, although you pretty much know that very well. But yes, energy efficiency investments can be financed from cost savings. So just to give an illustration of the potential that exists for energy performance contract market in the EU, the public sector annual energy bill amounts to 47 billion euros. So that really represents a large untapped savings potential. Improving energy efficiency in this sector and in other sectors provides really an opportunity to save public money, boost growth and job creation, improve the health of EU citizens, and very important, combat energy poverty and reduce our energy dependence. The energy performance contract market in the EU has still a long way to go before reaching its full potential. But it is really very important to have initiatives like AmBIENCe to support this market uptake. Before the entry into force, the concept of energy performance contracting was a novelty for most member states some years ago. The Energy Efficiency Directive has been instrumental in promoting the energy service market in the member states and has contributed, together with the Energy Performance of Building Directive, to achieve very significant energy savings in Europe. I would like to give you just a brief overview on the main objectives of the proposed Energy Efficiency Directive review. So there are mainly, we can say that there are mainly three main objectives why the Commission adopted such proposal. First, to get the unexploited energy savings potential across the EU economy. Second, and very important of course, to reflect the increased energy efficiency ambition as a consequence of the climate target plan. Because, as you can also see in the slide, energy efficiency is a precondition for all the decarbonization scenarios of the climate target plan. So it is, we can say energy efficiency is in any case a precondition for achieving the climate transition. Third, very important, provide member states with measures that are compatible with the increased ambition I mentioned, achieving this 55% reduction of greenhouse gases emissions by 2030. So to achieve these objectives, the EED revision contains quite, I would say, a very powerful set of measures. I think we can bundle all of them in five main elements. First, and very importantly, obviously, we need to start with the targets. So it proposed binding EU energy efficiency targets, but also indicative contributions at national level. It also goes a bit deeper in the application of the energy efficiency first principle, making this principle an integral part of the policy and the investment decisions. Third, strengthening the energy savings obligations in end use, mainly through Article 8, but also across different articles in the regulation, in the directive. Four, really that's also quite important, also has quite an influence also on the energy performance contract market, strengthening the exemplary role of the public sector. Finally, with an increased focus on alleviating energy poverty and consumer empowerment. I would like to zoom in now on the provisions that are more related to energy services, because that's really what energy performance contracts really are, no? When it comes to the Energy Efficiency Directive. So we have the Article 27 that has a number of novelties to reinforce the support to the market. So member states are encouraged the uptake of energy performance contracting by public bodies for the renovation of large buildings. When renovations of large non-residential buildings that are above 1,000 square meters occur, public bodies need to assess the feasibility of using energy performance contracting. Somehow it is putting in practice also the energy efficiency first principle with the very specific request to assess the feasibility for energy performance contracting. But also EED increased the role of advisory bodies, the independent market intermediaries, one-stop shops, or other similar mechanisms. As you know, a grand advantage of the energy performance contracting is its capacity to mobilize the private sector to provide financing, performance guarantees, and share risks. The commitment of the public sector to renovate and improve the performance of its buildings, it's fundamental because they account for 12% of the heated total floor space in the EU. So it's really very significant. Energy performance contracts are also suitable and relevant for the renovation of public lighting. And the increased potential could also develop in the use of EPCs for renovating district heating systems, the adoption of renewables, and for the smartification of infrastructures. Moreover, this commitment is key because the public sector plays an exemplary role in the development of building renovation and energy efficiency markets. I would also like to make some links with other articles on the ED proposal that somehow reinforced also the role of energy performance contracts. So energy audits could definitely trigger energy performance contracts uptake. And the ED sets provisions for conducting preliminary energy audits, and also change the scope of the application of energy audits obligation for SMEs definition to energy consumption. Skills. The requirements to ensure that the appropriate level of competences, the need to establish one-stop shops, and mechanisms to support the uptake of energy performance contracting should result in the further development of the market. Clearer and restricted requirements to ensure the necessary technical competence for energy service providers, energy auditors, energy managers, and installers. And finally, the link with finance. It's very important. So let me, also because I'm in charge of financing for energy efficiency, but I think it is also important to give you also an overview on what are the financing sources available in the, let's say, multi-annual financial framework of the EU budget that, as you know, goes by. So we are now in the 21-27 multi-annual financial framework. And indeed, financing is really key for boosting energy efficiency investments. We all know that, although I said at the beginning that it is, I mean, the situation we are in, it is really building the business case for energy efficiency. We all know that the demand is not always there compared to other sectors. So it's always a challenge to attract investments to the necessary scale for energy efficiency. But the EU has set, as I said, a very strong regulatory framework as part of the Fit for 55 package, but also has been very ambitious when it comes to the EU budget and the support to the climate transition and the support to energy efficiency. Out of the total 1,800 billion euros that will be made available by the EU in this MFF 21-27, 30% of this funding, of these resources, that represents around 550 billion euros, need to be dedicated to climate action. This means, when we compare to the previous MFF 14-20, that the resources for climate action has more than doubled compared to the period 14-20. So this is really good news. When it comes to energy efficiency, I think it is even more. I mean, it does increase even more. No? Just to give you one illustrative example. So in the previous MFF 14-20, cohesion policy funds was the main source of EU funding for energy efficiency, also for energy performance contracting. It amounted to around 17 billion euros in the whole period. Now, in the current MFF, only the Recovery and Resilience Facility is expected to dedicate around 60 billion euros to energy efficiency. So that's, this is multiplying by 4 the support, by 3, 4, the support provided within the cohesion policy funds in the previous MFF. So that's as I was saying, this is very good news. So the EU has set in a very ambitious legislative framework, but also very ambitious dedication to climate action, to energy efficiency within the EU budget. And of course, the multiple benefits of energy efficiency is one of the reasons why energy efficiency is a key priority for the EU, because of its potential to reduce the energy consumption, but also because of other multiple benefits that it has when it comes to creation local jobs, building a strong economy, etc., etc. And I will like to finalize my presentation with basically the three main elements of the financing measures of the renovation wave. As you said, AmBIENCE is very focused on buildings, and the renovation wave is really the strategy of the EU for the next years. We need to duplicate our renovation rates by 2030. This is really challenging. This is really challenging. But I would like to focus on these three main pillars because I think they are all, each three pillars, they are really have been, and they can really contribute a lot to boost the energy performance contract market in the EU. First is the EU funding, the public funding. We all know that it is really needed to act as a catalyst to trigger the investments, mostly in the private sector at the necessary scale. I already indicated the size of the Recovery and Resilience Facility, but also the cohesion policy funds will continue providing key support to energy efficiency in this MFF. Finally, InvestEU will be the key EU instrument to crowd in private capital. With the EU guarantee, this program will allow the development of targeted financial products and pre-development assistance. It is expected that InvestEU will provide dedicated financing support at EU level for the deployment of energy performance contracts. The second pillar of the financing elements of the renovation wave is very important, attracting private investments. And here, I would like to just focus on the first element, that we need to develop financial solutions that contains a high potential to be scale up, and that they are innovative. So I think here, energy performance contracting is really going into this direction. So the role of ExCos needs to be really amplified, and it was really saying the importance of the AmBIENCE project. And indeed, because I think it is matching energy performance contracting with also innovation and innovative financing schemes. And I think this is also very, very important, and is fully aligned with the EU policy on energy efficiency financing. So just to give another illustrative figure, I mean, we need more or less 3,000 billion euros by 2030 to be devoted to energy efficiency. The public sector may cover 15% maximum, but the rest need to come from the private sector, and that means private financing, but that also means investments by citizens, by us, by enterprises. So this pillar is key. Finally, that's my last slide, and I will come to an end now. Technical assistance and increasing capacities. This is really key, and it can really help upscaling standardization and replication of energy performance contracting to boost the ESCO market, but also to improve the awareness of municipalities, cities, regional local authorities, banks, and financial institutions. So with that, I would like to really congratulate the consortium for the excellent work that has been done, and it's been done as part of the AmBIENCE project, and for the fantastic work that has been done in the last 3 years, and trying to really stem the concept of energy performance contracting and develop innovative financing schemes with this approach of active building for project development, for energy performance contracting. Thank you very much, and I hope you have a very interesting and fruitful conference.
Thank you very much for this, Carlos. Following on this very good presentation from the Commission, we have a chance now to dig a bit more deeply into the policy context, into some of the barriers across member states, because it seems to me that this is a key moment, a make or break moment potentially for performance contracting. There's a lot of money available, there's the right political will, a lot of experience in the market, so now is the time to make this market scale. But of course, the devil's always in the details. So I believe we've got Valeria Palladino joining us online. Valeria is a permanent researcher at the Italian National Energy Agency, or Agency for New Technologies, Energy and Sustainable Economic Development. She's been there since at least 2014, doing a variety of research on the energy system and the clean energy transition. Is Valeria able to join us online now? So I'll hand over the floor to her, the virtual floor, to Valeria.
Valeria Palladino. Some noises, some. Can you hear me? Good morning. I think there are some noises in background. I don't know. Sorry. I think yes. Good morning, everyone. I'm Valeria Palladino, research scientist at ANEA, Italian National Agency for New Technologies, Energy and Sustainable Economic Development. I would like to thank all the participants, the consortium, and the moderator, Armin Meyer. The aim of this presentation is to show the active building EPC regulation. I don't know, I think there some problem, okay. With the current neighbors and barriers and actors involved in their services. The agenda is divided into several parts. The presentation is dedicated to the main results achieved by the project by the AmBIENCE Consortium, in particular, survey of directive policies, measure and regulation for active building EPC, EPC ESCO development status, the assessment of the demand response services offered by buildings, other factors enabling of the other EU member states, EPC and demand response, and finally, actors and rules for the area. In AmBIENCE Project, we made a comprehensive overview of the current situation, starting from consortium represented in the AmBIENCE Consortium, Italy, Belgium, Portugal, and Spain, by trying to understand which countries have the best legislative practice and offer the best environment for AmBIENCE concept and business model to succeed, and what are the current gaps in legislation and market awareness that might influence the successful deployment of the new concept proposed. The current status of each country for implementing the active building EPC, then assessed through a set of key areas covering aspects and as ESCO EPC status, demand response services, and other factors enabling the active building EPC. This critical assessment These include independent association and representative of utility suppliers. And amounted to 35% of total revenue. EPCs are most used in the commercial and offer sectors. Their penetration level is still low in the residential sector. What about for Belgium? Belgium follows Italy, where the energy service market is considered stable and moderately sized. From 2015 to 2020, ESCO's offering EPC has increased from 5 to 20. Private EPC facilitator is increased from 2 to 5. Facilitators play the role to provide technical, administrative, and financing assistance, in particular for the public administration. The number of public facilitators or one-stop shops has increased from 1 to 5. The number of EPC projects has grown to 5 to more of 35, while the number of buildings under contractor has increased from 20 to then 350. In Spain, the energy services market has been long awaited to boom, based on the complex set of government support measures. So Spain still faces significant barriers to implement active energy performance contracting. There are 1,238 companies registered as ESCOs. The total energy performance contracting turnover in Spain grew from 0.85 billion euro in 2014 to 1.2 billion euro in 2018. In 2018, also the EPC market was estimated to be worth around 1 billion euro annually. Office, hospitality, commercial, residential building are the main sector for EPC activity. And what about Portugal? Portugal is left behind the other countries represented in the consortium, with the lowest score for the key areas investigated. Indeed, the ESCO sector in Portugal can be currently considered is still underdeveloped and small. The EPC market turnover was about 30 million in 2018. 30 companies are registered as ESCOs. The number of companies registered as EPC facilitator or EPC provider is no more than 10. Despite this, current projects are spread across a range of building segments, and hospital, hotels are, and the public buildings, are the most common. And now we can talk about the assessment of demand response services offered by cluster of buildings. As we said, Belgium is the most advanced country in the consortium. In fact, over the last years, the Belgian transmission grid operators created a new framework to enable participation of new energy sources with new type of market players. While the implementation of this framework is still ongoing, the end goal is to open up to different products and services to all technology independently to the type of connection and the type of providers. This means that in the near future, all products will be adapted to become accessible to new future market parties. In Italy, the regulatory framework for the participants of the demand in the balancing market has been subject to substantial changes since 2017. In fact, the Italian Regulatory Authority for Electricity, Gas and Water undertook a complete review process of the ancillary services market with a view to opening it up to new providers. It did this by introducing the function of aggregators, aiming to increase the supply of essential network services. As for the product requirement, Italy, like Belgium, is experimenting with a new form of participation in the ancillary services market, according to the criteria of technological neutrality, in order to guarantee the supply of network services and improve integration of new providers in system. Instead, a totally different situation is found for Spain and Portugal, which are left behind the other countries. In particular, in Spain, there is no possibility for aggregated demand-side resources to take part in Spanish electricity markets. Aggregation is still not legal, and currently there is only one scheme allowing explicit demand response, which is the interrupter load program. Following Spain, Portugal regulatory regime for DR is very poor. There is currently no way for aggregated demand-side resources to play a role in its electricity market. For implicit DR, there are already some offered from the retails, but in a limited range. For explicit DR, there is no market and available offer of the service. In terms of products and market access, there exists a pilot testing the access to market of demand-side flexibility, but no solid scheme of market access is available yet. Aggregation, like Spain, is still not legal, and there is only one scheme, the interrupted load program, which allows explicit DR. Now we can talk about the other factors enabling the active EPC. The key area for the assessment of the other factors enabling the activity EPC are three. The direct flexibility exploitation. This area investigates to which extent the flexibility from there is exploited in the aggregator form for participation to the market. The demand-side flexibility on building level, this area investigates to which extent demand-side flexibility is exploited on building level, for instance, in the context of energy communities. Integration of energy and non-energy services refers to impacts often delivered by energy improvement behind energy savings. Some examples include improved indoor air quality due to enhanced ventilation, comfort, increased assets value, and productivity. The graphs show the different situations found for the consortium countries. And now we can see the extension of the analysis to the other EU member states. For the EPC ESCO, the most advanced countries in Europe are Austria, Czech Republic, Denmark, Germany, and the United Kingdom, which are characterized by a more mature market fostered by a well-developed legal framework addressing EPC contracting. The list of the countries which an ESCO EPC market still in initiation phase much longer, and in general, it is found that these countries belong to the Eastern Europe, characterized by the lack of legal framework regarding Estonia and Malta do not still have an ESCO EPC market. While for demand response services, it is found the most advanced country in Europe are Finland and Ireland, where demand response participation is allowed in multiple electricity market. Also in this case, the countries belong to the Eastern Europe are in initiation phase. Cyprus and Estonia are left behind the other countries. And now we can see the overview of many enablers and barriers for EPC and demand response. For Italy, the many EPC ESCO enablers are summarized below. The very high competence of ESCO, responsibility borne by the ESCO through an EPC contract. All types of duties are borne by ESCO, and this is appreciated by the customer. Normative obligation. The preparation of energy audits had led to efficiency accession, in many cases carried out by ESCOs. Incentives management. The ESCO normally manages incentives deduction granted by law on behalf of the customer, who receives indirect economic benefit. The main enablers for demand response services offered by cluster of buildings are the ongoing review of the regulatory framework, both for concept of technological neutrality and in order to allow independent aggregators. The ongoing revision of minimum performance requirements for each ancillary services set. And finally, consumers' data availability in real time made possible through the plan established for the rollout of 2G smart meters. For Italy, the main EPC ESCO's barriers are the contractual complexity of EPC, the lasting committing with the ESCO, the complex calculation method for savings. EPCs provide formulas and methods for calculating savings that are difficult to understand for decision makers who lack technological skills. The uncertainty about the EPC ESCO, the absence of historical monitoring data. The main barrier, for DRS services offered by cluster of building is historical restriction, which characterize the national building stocks. For historical buildings, improving the energy performance could affect the monumental value of the building. For Belgium, the main EPCS enablers are the presence of a strong legislative background, the very high competence of the ESCO, like Italy, the guarantee results, the presence of a national ESCO association, the creation of several public one-stop shops, and the strong focus on innovation by some market and project facilitators. The main enablers for demand response services offered by cluster or building are the ongoing revision of the regulatory framework, the well-established regulatory framework for accepting independent aggregators and for revision of the minimum performance requirement, and the standardized and clear measurement and verification procedures. For Belgium, the main EPC ESCOs barriers are the contractual complexity of EPCs. The complex political system leads to fundamental difference in approaches and priorities in free regions, making it difficult for EPC market stakeholders to engage with policymakers to define consistent regulation and policies measured across the country. The lack of awareness about the benefit of EPC, the absence of historical monitoring data. The main barrier for the demand response services offered by cluster of building is the regulation on integration of energy services and non-energy services is limited to energy performance building. And what about for Spain? The main EPC ESCOs barriers are administrative and financial barriers. Sure, the public procurement process is lengthy and inefficient. The lack of knowledge and trust both toward the EPC business model and its providers. The lack of standard and enforced measurement and verification protocols, and also, the duration of contracts. The main barriers for demand response services offered by cluster of building are legal barrier, lack of flexibility in regulation to enable innovation and demand participation in the market. The market barriers, limited access to flexibility market, balancing markets and demand responses market are close to distributed energy resources. Technical barriers, the lack of interoperability, reliability issues, cybersecurity issues. Social barriers, the lack of knowledge for changing the end user behavior. And finally, the policies barrier, absence of a policy framework fostering demand side flexibility. For Portugal, the main EPC ESCO barriers are essentially the barriers very similar to those of Spain. In fact, there are the same administrative and financial barriers, the lack of knowledge and trust, the lack of standard and enforced measurement and verification protocol, the duration of a contract, the level of risk involved in a project may be perceived as too high by the prospective clients due to the duration of a contract. The main barriers for DRS services also in this case are legal, the regulation to enable innovation and participation, the market lack flexibility, the market barriers, the technical barriers, the social barriers. More knowledge is needed on how to change end users' behavior to provide flexibility services. And finally, policies barriers. And now we can see the actors and the rules involved for the demand response services. The first difference relative to the flexibility regards the subdivision between explicit and implicit signals. When demand-side resources are negotiated on energy markets, wholesale balancing and ancillary services, and sometimes also capacity mechanisms, we talk about explicit demand. Implicit DERA involves the time variation of energy price and network tariffs, since this mechanism indicates the value and cost of energy at different points. And among the most important actors could be distinguished 8 rules. The supply retail actors are responsible for the supply of electricity to customers, thanks to the contractual agreement with the grid operator. The consumer actor who employs the electricity supplied in possession of energy supply contracts Prosumers also are defined as consumers who, possessing their resources, can actively take part in the energetic system. The aggregator, sure, defined as a natural or legal individual who represents several customer loads or generated electricity for sales in any electricity market. They also facilitate the interaction between the energy supply and consumer. The TSO represents a legal entity who operates to ensure the correct operating and maintaining of the transmission electricity grid. The DSO defines the actor in charge of the operating and maintaining a distribution grid and responsible for the system interaction and their future demand for electricity distribution. The BPR are responsible for the balancing between for the balancing between the injection and the off takes. Oops. And off takes. And finally, the energy services company ESCOS. Thank you. This is my last slide. Thank you for all your attention.
Really good presentation, really good presentation, really good presentation, really good presentation. Fantastic to see a real deep dive on the barriers, which I thought was very helpful. Obviously, a lot of work to do across Europe to scale this market, but it's great to have a head start to understand issues in more detail. Just a note on the agenda, we're about 10 to 15 minutes behind, so we'll still try to keep the coffee break at 10:30 to make sure we catch up with that. So hopefully after Jesse's presentation, we'll have a bit of time for questions. But without further ado, next speaker is Jesse Glicker from the BPIE. I had the pleasure to work with Jesse at the International Energy Agency as well at some point in time ago. In the Energy Efficiency Division, we worked a lot on ESCOs, so I trust her judgment and views very much on the sector. And welcome to the floor, Jesse. Thank you. I switched it off, sorry. I switched it off.
Being on mute, but in person. So a quick adjustment to presenting finally back in person. I will hopefully make up a bit for our lost time. This is just, I click this for the next slide? Yeah, good. Okay, I'll make up a little bit for our lack of time. So I'm going to be presenting policy recommendations on the way forward based on sort of everything you've heard this morning and some of the lessons learned we'll discuss this afternoon. So just a quick overview. I'll talk quickly about the methodology, where we got these recommendations from, and then go into the key recommendations, which have been split into regulatory, financial, and administrative recommendations. Just a quick note, they're very high-level recommendations at this point. We just heard from Valeria a very in-depth overview of where we got a lot of these recommendations in terms of the barriers and enablers per country, primarily focused on the consortium countries, but also focusing on the EU as a whole. So we really took a lot of the lessons learned that were applicable across countries to really be able to apply these recommendations on the large scale across the EU. So the methodology, a lot of these recommendations came from a literature review conducted, an analysis that was done throughout the project that you just heard the results from Valeria, the pilot learnings, which you'll hear more about this afternoon, or later today, later this morning, and the stakeholder workshops, which were conducted throughout the project, which were very informative to be able to run the ideas by those in the consortium and get their feedback, those member countries in the consortium and get their feedback. So the first set of recommendations are regulatory. So this really affects the role of demand response and who can participate in the wholesale balancing and ancillary markets. There's a little mistake. I wrote balancing. That should be energy markets. That's all markets in terms of wholesale balancing and the ancillary markets. So the review process carried out illustrates where there are issues with regulation, either affecting energy performance contracting or demand response and flexibility. Of course, energy performance contracting has been around for a while now, so what we were focusing on is this nexus between energy performance contracting and demand response. So the regulatory component highly affects where things are in terms of implementing the active component of energy performance contracting. So it seems a bit sort of simple to say, but really conducting a review of the relevant regulation in each country that's looking to implement active energy performance contracting and carrying out a revision based on that review and establishing an enabling framework for active energy performance contracting. We saw two good examples discussed by Valeria in Belgium and in Italy, where an overview was conducted and revisions are being made based on the regulation and the issues that were found. Implementing dynamic tariffs, this helps, of course, when you're talking about flexibility and people reacting to the market, and ensuring clear long-term policy. So, of course, all of the other things, review, revision, an enabling framework are all great, but if you don't have clear long-term policy established and well communicated, it's very hard for those in the market to stay up to date and to implement and act on the policy measures that are being established. So the next, and we've heard about this, and Carlos's presentation also touched on this, was very important, is the financial component. When we talk about energy efficiency, always finance is a big issue. Energy performance contracting, in a way, pays for itself, although we do need measures and financial instruments that will help de-risk and stimulate that demand. So one of the first things is a strong ESCO market. So a strong ESCO market that is able to carry out active energy performance contracts and therefore adapt and also include that active component. Then establish a guarantee fund. This goes hand in hand with the second one, which is a fund to provide CapEx. Of course, a guarantee fund will help with the de-risking of all of the upfront costs that someone has to pay, whether or not it's the bank, the ESCO, the homeowner, building owner. So ways to really create that demand and help, de-risk the issues with people who are thinking, oh God, I don't want to put up all this money up front. Support for research and development for innovative technologies. It's a huge one, especially when we're talking about interoperability and new components and new ways that we're incorporating flexibility and how that is communicated back to the homeowner and the building user. And then tailored financial incentives. So subsidies, tax incentive, earmarks, recovery funds, et cetera. So it was in Carlos's presentation, we saw all of the money that is being set aside in the MFF and in the recovery funds. I mean, really tailoring a lot of those funds for ways to support the implementation of active energy performance contracting. Fortunately, and this is something we hear a lot, the money is there, the willingness is there, it's aligning the two and really specifically outlining what that money will go toward and how it will, in this case, go toward active energy performance contracting. And so finally, we've got the administrative recommendations. So one of the things we heard quite a bit from Valeria was this is all complex, whether it's active or whether it's energy performance contracting, whether it's demand response, flexibility, interoperability, all of these things. We've got a lot of different market players. There's a lot of complexity that people need help with. So establishing one-stop shops, we've heard this one already this morning, as a tool, as a way to administer the technical assistance that is needed, simplifying and standardizing data collection. Again, especially with the ESCO market, this is a big one, ways to really facilitate the counting of the market, how things are, the measurement and verification, how that's working in a building, where all of that is being transferred and stored. So in that, looking at the smart readiness indicator, tailored support plans on behalf of the EU to help member states implement their SRI. This is something that is in the process of happening, but really facilitating that so that there's some standardization across the EU and looking at where different countries are and bringing everyone up to a certain functional level, especially considering it is voluntary, and also the implementation of a European-wide digital building logbook, another one that's currently underway, and figuring out and making sure that there are specific provisions for things like counting flexibility and valorizing demand response as a way to track the market and therefore establish the benefits of active energy performance contracting so that it becomes easier and easier to continually implement. So I think I saved us some time there. And that is the end of my presentation.
Annick, if you're okay to join the stage for a moment, Jesse, if you have a seat there. We have a bit of time, about 10 minutes for Q&A. Please take a seat. And we also have, I have a screen here with questions from the online audience. So I know you're all burning with questions. And please, the floor is yours, dear audience, if you'd like to pose any questions. I think we have a roving mic as well if somebody needs to use that to go around. It's just here. Thanks again to all of you, by the way, for very good presentations this morning. Is Valeria still online to take questions as well? We have one question here from Claire Harvey from EDP. Please go ahead.
Yeah, it's probably for Valeria.
Just 1 second, I'll get you a mic so the audience and online can hear you as well.
Hello, yes, Claire from EDP. I'd like to ask a question regarding the EPC market in Italy, why the ESCO market is so advanced in Italy. We saw that one of the main enablers in Italy was the legislative conditions there. But I'd wonder who are the players in Italy that are facilitating these EPCs? Is it big utilities or is it more smaller ESCOs? Who makes up the ESCO market in Italy? If someone has an insight on that.
You might be on mute, Valeria.
Can you hear me?
Yes.
Okay, okay. There is some problem with the connection. Okay. In Italy, the regulatory framework also in the last years are very frequently changes with most of opportunities for customer and for ESCO to do good things for the incentives, measurement, and for the verification of the results. And this is applied in many factors, but not very effort is for building sectors, for residential, sorry. And I think there is a good work, but many other opportunities can do for the customer, for changing the behavior. I think the most important actor involved in this function is since the ESCO, since the regulatory, but also the customer that have to change its behavior energetic. And I think the energy communities would also improve these factors.
Thank you, Valeria. Any further questions from the audience? Now is your chance. We have one here on the front from Chris Katz from Vito.
Hi, thank you. Well, we know there's a lot of money available for doing these, say, energy efficiency related measures and renovations. There's a lot of focus and high ambitions on driving forward these deep renovations and like this magical 3% per year number. While in reality we see that what's happening is like way less. Is there a view on what's really causing these delays? Because it's not that there's no money, I think. Maybe money is not found, or are there other reasons? And now, what do you think we could do to address this challenge? Yeah? Because if we don't step up, we know it's very urgent. We cannot wait till 2050 to do stuff.
So I guess a
I
general...
don't expect a silver bullet answer, but maybe some some reflection on this would be interesting.
So a general question, I guess, on how to accelerate. Would any of you like to?
I think one of the main things that can really bridge that gap is a skilled labor force. I think there needs to be a bigger focus on the people actually implementing these projects. There's a backlog always, I think, in these projects, and the timeline, people are hesitant to undertake these measures because it'll take too long, they have to wait, there's issues with getting the right people, and so I think really tackling that, and like you were saying, there's funding there's more or less political will, but it's a matter of linking the two, and that's when it comes to implementation and who will implement it.
Thank you. Question from Levin here in the front. Mike is coming to you.
Thank you. I have a question to Mr. Sanchez in that sense. Sorry. Picking into what Jesse was saying, isn't there an issue of not just skilled labor force, but of resources in general, human resources throughout the sector? If you look at the challenge, you're focusing a lot on technical solutions and financing solutions, and they are always slower than we hope for. But if they are there, I have the impression that one of the bigger bottlenecks is going to be resources, but at all levels. Project managers, architects, engineers, you name it, and then of course also construction workers. Sorry.
From the top again.
Yes. Okay. Yeah. So summarizing. So my question to Mr. Sanchez that there is an issue, I think, of human resources to do these ambitious energy transitions and building renovations, from architects to engineers and down to the skilled workers. How much is the Commission aware of that, and what efforts can be done so that all the EPC projects that could potentially be done and the AEPC projects could also effectively be put in the market and realized? Thank you.
No, thank you very much. I think that's an interesting question indeed. I mean, addressing the challenges that we have ahead is not easy. It's not easy, and I agree that we have quite a number of challenges. And you mentioned resources, and indeed, resources is key. So it is human resources. Also, it will be affecting also the lack of materials, the lack of products, problems in the supply chain, etc., etc. So skills, resources is key. It is. We are working quite intensively in this area as part of the Commission. That has been identified also as part of the renovation wave strategy. Also as part of the EPBD, we are really going in this direction, trying to find ways how we can really somehow close this gap that exists. So that's one of the main challenges, and we are really fully aware of that. We are really working on that. I think it is important to have all the actors in the value chain working together, and this is what we are working on right now within the Commission.
Thank you very much, Carlos. From the online audience, any questions? I'm not sure where to look to address them, but anywhere. If you're out there, if you have a question, we still have a bit of time. And from the audience, anyone? Yep, right here. Please introduce yourself as well. Please.
Hi, my name is Matthijs. I work for the Flemish Energy and Climate Agency. I have a maybe more low-level or pragmatic question. I'm not sure who to direct it to, but the slide, I think it was Annick's slide, where you showed the normal energy performance contracting versus the active building energy performance contracting. And I was wondering, is there there must be a difference in upfront costs because you have to invest in all the sensors and the energy management system and all that. Is there a kind of an estimate of what the difference in upfront financing is?
So perhaps a question to address to you, Annick, but if anyone has thoughts on the cost differential essentially between a standard EPC and an active EPC?
Honestly, we didn't really check that, although sensors are not that expensive, because we know that we have had to place a lot of sensors in the pilots, and they were rather cheap, I would say. But you have to check. I don't know if the people from the pilots have tackled that issue.
It's something that might come up in the panel discussion as well, and I spoke about it with Lieven and also Gregory Tilte from ICWANS. Perhaps the cost is ultimately very similar or the same in the sense that the building itself, to be able to participate in flexibility markets, has to have a certain level of insulation performance, ideally some electrification and ability to respond to the grid, smart meters, for example. So perhaps the challenge is ultimately the same in terms of getting the building stock to a better level of performance across the board. We have one more question from Chris, I think, just up here. Yeah.
I think you're right, Armin. But next to that, I think you also see anyway there's a lot of say, thought going to improving comfort in buildings, and a lot of things that you would invest just to reach that, to have better comfort and better awareness, I think, can be reused for this active demand-related functionality. So I think if you would really look at the specific additional cost specifically related to the active control part, would be rather limited. But we didn't really quantify it very precisely.
Great, thank you for that. Lieven has a follow-up question, I believe. From Lieven over here, yeah. Oh, another question. Sorry, I didn't see that. Maybe first to Lieven and then over.
Just to quickly add to the answer also, with energy performance contracting, we do not look only at costs, of course. We always look at benefits. And it's a TCO approach, total cost of ownership. And we see, in fact, that the business case of the active control on top of the renovation is, in fact, much better. We're talking about much lower cost and, of course, also much less savings. But the business case as such is better than the one of the deep renovation.
Thank you, Lieven. So I had a question from the gentleman over here, I believe. Yeah. And please just introduce yourself briefly when you...
Thank you, Alexander Simonovic from Honeywell. Just a simple question. I know from EED, it's an energy directive, there were some obligations. I know with the Fit for 55, this is a revision of the EED. Will be there new obligation, like because you said that ESCOs and energy performance contract will be key energy efficiency to deliver the new Fit for 55 revision of EED. Will be there some obligation for EPC or will be?
No, thank you very much. And I mean, the Commission adopted this proposal for the review of it's not working properly? No, okay. Now, the Commission adopted its proposal for the review of the EED, of the Energy Efficiency Directive, last July 2021, basically. And it contains, of course, reinforced measures across the board in all different sectors and articles. And also, in particular, as I presented during my presentation, also including on energy performance contracting. It is already existing Article 27, but also other articles that are more horizontal ones that are really helping to establish and to set a strong energy performance contracting markets. So there are, as I presented, some additional considerations now in the proposal for the EPBD, such as, for instance, the need and the obligation for public authorities to assess the feasibility of using energy performance contracting for the renovation of non-residential buildings that are above 1,000 square meters. So this is one of the elements. There is also the element of the exemplary role of the public sector, where we are asking the public sector to renovate the next percentage of buildings every year. So that also creates quite, I think, a huge potential for energy performance contracting in the market. But there are more elements, such as, for instance, the request for reporting requirements from member states on energy performance contracting as well. There's also a boost for further go with using the energy performance contracting that are Maastricht neutral, so they can go off the balance sheet, etc., etc. And there, as I mentioned, a lot of provisions on really reinforcing financing elements and other horizontal elements. So yes, I mean, we can conclude that the ED proposal is really reinforcing all the provisions on affecting ESCOs and performance contracting.
Thank you very much, Carlos. And I think that's probably all the time we have for now. We'll move to the coffee break. We're meant to be back at 10:45. Shall we make it 10:50? So 10 minutes to 11. Please come back in the room and for the online audience as well. And we'll start again promptly at that time. Thank you very much for your contributions. And thanks again to all the speakers, please. Thank you.
Thank you.
That's good. That's good. Well done. Yeah. Good performance. Right. So very pleased to announce our next speaker, Lieven van Stralen, who has been active in this space for quite some time. He's the founder of the Belgian ESCO Association in 2010. He also is co-founder of Energy Invest, which is a specialized consultancy working in this field since 2011. He's brings a tremendous amount of experience to the topic, and he'll take us through now the business models and the AEPC contract structure in a bit more detail. Lieven, please.
So thank you very much, Armin, and thank you everybody for being present here also from our side. I do bring in quite a lot of experience, but particularly in the energy performance contracting field, and I must say that this project also gave me the opportunity to learn a lot about flexibility and demand response, which was quite new to me, and so that was a great exchange also with other colleagues. So today I'm going to say a few words about the business models and the AEPC contracts templates that we developed and the contracts for the pilots. Before doing that, maybe just quickly going to this slide because I think it introduced the business models quite well. One of the things, of course, that we had been doing in the past is looking at the value chain of energy services or energy contracting, starting from the primary energy delivered all the way down to the building on the right side, with secondary energy, then what we call useful energy, and finally energy savings, with business models like the ones that some of you may know already, also like energy supply contracting and delivering useful energy, heat, cold, those types of energies to the building, and managed by ESCOs. And ESCOs manage, for example, the CHP plant or the boilers to deliver that heat, for example, to the building. And then we have the whole energy performance contracting part, delivering savings into the building, reducing demand. And that comes also in various flavors. I won't go into this detail. But what we, of course, have been doing is extending that value chain with the flexibility, with the demand response into the AEPC model. So we have in this value chain energy supply contracting, performance contracting, and then active building performance contracting. So when we look at the business model, okay, there's a lot of things to say about the business model. I think you've understood the essentials. So we're trying to renovate buildings, trying to find an optimal also through electrification, not necessarily insulating all the way, but finding that optimal point, and then adding the active control to exploit flexibility, either explicitly or implicitly, with a stronger focus, let's say, in our work on the implicit demand response, using the dynamic tariffs, of course. So when we looked at how does this business model look like, who are the actors involved, the stakeholders, how do they interact, how do they create value, and how do we monetize basically that value, or how do we create value, for example, out of the CO2 savings? There were several different parameters that came along that analysis. One is the building type, and doing such a project in a residential building or a commercial building or social housing. Yes, in a large sense, it's the same business model, but it becomes specific depending on how the buildings are there. Are they collective? Are they individual? And so on. Also, the occupation module can be individual occupants, can be a large apartment building with many tenants, and so on. The type of demand response, already touched upon that, implicit versus explicit. And then the owner-tenant relationship as well. Is the owner occupying the building, or is there a tenant leasing the space? And is there a social component which changes the relation also between tenant and occupant and owner, sorry. And then the financing mechanism, typically ESCO financing versus financing through financial institutions and so forth. So these were the various parameters we looked at, and we came up with first of all, with like a more generic scheme of what the business model looked like, with the key actors being, of course, the owner, in this generic case, owner-occupier, with the ESCO delivering the energy, savings and the flexibility management, so the active building EPC contract, being financed by a financier, possibly subcontracting part of the solution. And then, of course, there's the important role of the electricity supplier. He's the one that invoices the electricity, but also provides, of course, the opportunity for the more dynamic pricing. And then finally, an actor that has been recognized throughout the EPC projects is the role of the facilitator, assisting the building owner in his project, and that role doesn't fundamentally change. There are some additional services that are also being, that can be delivered by the facilitator. So this is the most generic model. And then we decline that into various models. I will not go into detail of each model, of course, it would bring us much too far. But you see, for example, here, a variation with explicit demand response, linking it basically to the systems operator, the DSO or TSO, asking for flexibility, for specific requests that are done through, often already today, for example, in industry, that are being valorized on a call basis through the aggregator. So that's the first variation. This is another variation where the ESCO, given the fact that he has many, many buildings, or maybe several hundreds or thousands of buildings in his portfolio that he is managing through various APC projects in the future, then has basically the volume to sell that volume to the aggregator, who in itself then sells it off to the DSO, TSO. And if you go, again, a step further, the ESCO himself can become a technical aggregator of demand response because of the volume that he represents. And so you see also a shift of responsibility, of opportunity from existing market access possibly to through the ESCOs. And finally, that could mean that the ESCO himself becomes a full aggregator, delivering an explicit demand response to these system operators. So you see there's also a potential market evolution hidden within these variations of the business model. And this finally, this is one that is quite interesting because we were somehow testing it already in other projects. It's about social housing companies, where you also have a huge opportunity in building renovation, even today with very, very efficient integrated renovations, where there's also an ESCO that does the design, the build, possibly financing, and then the maintenance and operations. With, in this case, for example, financing from the global umbrella organization sitting on top of social housing companies. But the interesting thing here is, of course, that again, you can manage flexibility across a full neighborhood with playing with the auto consumption levels of the PV panels, playing with the terrace, playing even with home batteries or eventually neighborhood batteries, for example. That's the type of business model that is reflected here. And then, of course, you have the social tenant. He's the one, of course, benefiting from the energy savings and the cost savings, and they can be quite substantial. But you also were testing other arrangements where part of those savings also somehow return to the social housing company. And that's what you have to do, basically, in such a business model, is to try to look at the full picture and optimize it for all players. So this is just a quick summary of all the models. I gave a small section of some of the important ones, but in total, there were about 15 different variations looked at and analyzed, and they are in the deliverable that is available. What we, of course, also looked at, looking at the contracts, because we designed contract templates, and we designed for the Belgian and Portuguese pilot specific contracts based on those templates. And to do so, we, of course, needed somehow measurement and verification guidelines. They are key to any EPC contract. That's not different from AEPC. But we had to look at what are the new challenges while we introduce flexibility in those projects in terms of measurement and verification. And one important one is, of course, the dynamic pricing, because we're not only looking at kilowatt-hour savings, we're looking at cost savings, we're looking at CO2 savings, and how do we measure those with the dynamics of such contracts and the usage of them. And so that's where we designed like a preliminary MNV guideline document to be used in those contracts. If you look at the contracts themselves, so 2 APC contract templates were developed based on an existing EPC template or templates, because they were also a little bit redesigned. As I said, applied to both pilots with quite a structured approach, with different schedules, with different exhibits, with different annexes and appendices, and then integrating those MNV plans, as I mentioned. And this slide, it's probably a bit small, but it just gives you a summary of the content as is being used. The difficulty, of course, in Europe is also that there's many legislations. You have commercial contracts, public contracts, so it was not easy to develop like a contract that could be used necessarily everywhere in every contract, but at least we tried to do something focusing not so much on the legal stuff, but more on the technical stuff and on what administratively, operationally has to be in the contract. And then starting from that, okay, we can adapt such contract templates, of course, and probably in the future, if more and more APC is being used, other people may come up with variations. But it was really pointing out the key aspects in such contracts. And this gives you an idea of what we at least thought was useful to have in the templates. And that's it for me. Thank you very much. If you have any questions, maybe later on.
Thank you very much, Lieven. That was really great to see all the work that's gone into developing contracts, especially. I'll permit myself a little plug. I also work on something called ESCO in a Box with colleagues in the UK, looking at smaller community-scale ESCO projects. And here, the importance of having contracts is huge. Just the mechanics around ESCOs can be, and EPCs can be a bit complex, so having those templates in place is really critical. Introducing next speaker, Claire Harvey. She's with the Portuguese utility EDP. She's an R&D engineer and project manager. She's got a double degree in energy engineering and management, and she's been active in the energy sector across Europe. She's going to present work from the Portuguese pilot, and she'll join us on the panel later. Just after Claire, Lieven's going to come back on stage, so I'll ask you just to come directly as well to present the Belgian pilot findings. Thank you.
Okay, the microphone's on. Can you hear me? Okay, thank you, Armin. And yes, today I will present the APC in practice. So how we applied the AmBIENCE methodology in 2 pilots, one in Portugal and one in Belgium. I will give a quick overview of what was demonstrated and how we applied the concept, and have an overall learnings from both of the pilot buildings. And then we'll dive into the results from each of the pilot, where Lieven will present the Belgian case and I will present the Portuguese case. So yeah, as an introduction, the pilot buildings demonstrated different applications of the APC methodology. One was in Portugal, one in Belgium, as I said, so across different climatic areas and with different national regulations and so on. The Portuguese pilot is a commercial office building, while the Belgian pilot is a residential building. So very different stakeholders involved across the APC process. The proposed measures for each of the cases was classic energy efficiency measures plus demand response. And in these cases, as is most viable with the current market structures, it was implicit demand response, so making use of different energy prices throughout the day, the time of use tariffs. So the APC process is divided into 3 different phases. We have the pre-contracting phase, which is general analysis on the potential of a building for an APC, and calculations on potential savings and required investment, involving site surveys, client engagement, analysis of the data, more data collection, flexibility assessment, and so on. Then we have the contracting phase, which looks at these calculations, simulations, and quantifies that into measures and guarantees that can be put into a contract. defining the baseline and the guarantees for the ESCO and the client relating to these energy efficiency measures and demand response. Also in this phase includes the deployment and installation of any energy efficiency equipment or devices for the demand response, so sensors and actuators to enable active control. Now, after contract signature would be the performance phase. So this is when the building is actively monitored and managed, where the savings, the cost savings and flexibility operation is verified, and any baseline or reference calculations are corrected from new data collection throughout the operational phase. For example, if there's a change in the weather conditions or the occupancy or any other differentiating factor from the assumptions that were made in the baseline. So the duration of these phases depends very much on the country, on the building type, the stakeholders involved, ranging from months to years, with continual client engagement right up to the contract signature, and then as well continual contact with the client during the performance phase. And the pilots for AmBIENCE were able to pass through key stages of these processes, of the pre-contracting phase and some stages of the contracting phase. However, for a real implementation of the contract, further implementation steps are required, which were not possible during the time frame of the project. So to be able to design an EPC contract, as Annick mentioned in her presentation earlier, the AmBIENCE proof of concept platform was used. So with all the information from the building, the first step was to build a flex model of each of the pilot buildings. This included gathering data on environmental conditions, historical energy consumption of controllable, uncontrollable loads, the setup of the building, the type of devices that are there. And with this, a dynamic thermal model of each of the pilot buildings was generated. And this is for before and after the measures are implemented. This dynamic thermal model is then used in different modules of the AmBIENCE platform. So we can see module 2, the energy cost cash flow estimation subtool, calculated the baseline operational cost of each building, and as well as this, the reference operational cost, once we've applied these energy efficiency and demand response measures. And then the results from that feed the financial and economic calculation tool, which allows you to calculate overall operational cost savings. So taking into account these investment costs of the different measures and different scenarios, so that the ESCO can see these different KPIs such as return on investment, NPV, and so on, to be able to develop the contract. So that's overall what we applied to both pilots. Just before we go into the results of each, a brief overview of some of the most important lessons learned while applying this methodology across both of the buildings. We can say that client and stakeholder engagement activities are key, even before the pre-contracting activities and throughout all the phases. To have buy-in from the stakeholders is essential. And this can be complex and different depending on the building type. It's very different for residential compared to commercial, different compared to the country you're operating in. But it's key that there's trust between the ESCO and the client, and the potential value is communicated from the offset. Now, this is a challenge, I think, even for standard EPCs. So when we add this extra complexity with the quantification of flexibility for the client to understand, it can increase this challenge. So leading to the second key lesson is simplifying the need to simplify complex design options into understandable benefits. So flexibility of equipment and assets is quite a well-known concept for energy engineers and so on. And when you're trying to explain a simple example, it's okay. But when we go to buildings, which can be quite complex, things like the thermal mass of the building, the complex interaction between multiple different systems, the influence of external factors such as occupancy, weather, etc. It's not so straightforward to the client, and even in the ESCO sometimes to understand. So the calculations therefore need to be transparent and trustable for these performance guarantees to be generated, ensuring that all assumptions are recorded. Simultaneously, communicating the potential value of this complex subject is key to have it in simplified terms, so it's straightforward for the client to understand, and that will be key in streamlining the contract development and signing process. And the third key lesson is that the value is there. We have seen significant operational cost savings that can be achieved through this operation of the optimization of the operation of flexible assets. And in many cases, this requires significantly less upfront investment cost than some traditional energy efficiency measures, which decreases the payback period compared to classic EPCs with only standard energy efficiency measures. So ESCOs who are able to understand and tap into this potential will be able to generate competitive contracts and reach new markets. Okay, so now delving into the pilots themselves. I'll explain briefly the Portuguese pilot. So the pilot building in Porto is an office building. It was built in 2011, a large office building with 10 floors. Most of them being open office spaces that are climatized through a centralized HVAC system. There's also 3 underground floors with EV chargers planned to be installed this year, and around 600 users, although this changed during the COVID times, and now we're in a hybrid working model, which is an important thing to note when it comes to these type of contracts. It's energy class B-, and it already has some efficient measures implemented in the building. There's some solar PV that's already all self-consumed, mainly LED lighting, and it's controlled via central BMS. And the building is fully electric, so no mains gas consumption, making it a good candidate to make use of flexible electrical loads. Now, in terms of stakeholders involved, the pilot building is rather unique, seeing that many of the relevant roles in the AEPC process are of the same utility group, that's EDP. However, EDP is a large utility with over 12,000 employees worldwide, so each of these business units work independently and have their own decision-making processes and paces. But we can see that the ESCO role can be taken by EDP Comercial, which is the retailer branch of our utility, which has an energy services department. The owner of the building is EDP Group itself, the mother company of the utility. And the building manager is a specific company called EDP Global Solutions, who act as an asset management company. And they would be the ones in our pilot case who would be the beneficiary, the client of the AEPC, since it's the entity responsible for paying energy bills, approving any energy efficiency measure, or investing in building on infrastructure. One role, however, that's not from EDP is the maintenance company, who's an outsourced facility management company, and mentioned here because they really are key within making this concept operational. So a unique mix of stakeholders makes for a unique business model as well for the Portuguese pilot building. We're an adaptation of one of the business models that Lieven has presented is foreseen, with the characteristics seen here. But special to mention is the financing part, that the client would actually provide its own financing, since they have the capacity to do it. And so the ESCO compensation would be through the guaranteed cost savings, and a bonus-malus scheme would be foreseen for over or under performance. So now on to the measures themselves for the Portuguese pilot building. The building, as I said, already has some energy efficiency measures by design, but the ones foreseen for the AEPC contract are the 5 listed below. The first 3 are, you could say, traditional measures from an AEPC, so increasing the PV capacity, replacing the rest of the lights with LEDs, and installation of variable speed drives within the electric motors of the larger pumps in the buildings. And these account for around 8% of yearly cost savings with our simulations. The last 2 measures, we can say have a significantly less investment cost up front. The first one is just standby optimization of the ventilation units, so a conservative 2 hours per day of not operating the air handling units. And the 5th one is the demand response that was optimized through our platforms, the smart heating and cooling. So maintaining the comfort of the building, we took the thermal model and optimized to shift energy consumption to different time of use tariffs during the day to be able to generate cost savings. And this gave an additional 6%. So The proposed measures for our APC gave a 14% yearly cost saving. So looking specifically to measure 5, because it's the one that's the innovative case and differentiates a bit from the classical APC. The HVAC system was chosen as the controllable load where demand response could result in operational cost savings on top of these energy efficiency measures. Smart operation of the HVAC allows us to optimize the set points based on these different time of use tariffs, all the while respecting predefined comfort levels for different times of the day. So the AmBIENCE platform, as Annick explained, simulated this measure of smart heating and cooling, optimizing the heating and cooling throughout the year. And we can see here an example of one day, the heating, the optimization of the heating. The first one is heating without smart control, and the bottom with smart control. So as I said, shifting the thermal power input to periods out with the peak tariff period, which achieves significant savings in terms of cost. So from all these calculations from the AmBIENCE and other modules with AmBIENCE, insights from the local stakeholders, the AAPC template contract was developed for the Portuguese pilot. As Lieven's described, it has extensive sections and a framework, but I'll mention just a few important parts of the contract that we consider. So the baseline accuracy is a really important part of that contract. When we compare the results from AmBIENCE on the right, our simulations, to the simulations from the energy certificate, as well as real historical data from the building, we can see that from this it seems viable. But all assumptions that were used to create the baseline need to be stipulated in the contract. And this baseline model, throughout the performance phase of the contract, would have to be updated should there be any change in regard to these assumptions by applying routine or non-routine correction factors. So like the weather conditions, the electricity prices, as Lieven mentioned, or occupancy. Now, sensitivity analysis on various financial parameters would allow the ESCO and the client to understand the risk potential gains and potential losses. As an example here, results of 3 different scenarios based on a different inflation rate are shown, where the NPV, IRR, and rate of return are varying depending on this inflation rate. So the ESCO and the client can decide which risk level they want to take in the contract development. So these analyses ultimately result in cost guarantees, where savings in our case are monetary in terms of instead of energy, due to the fact that the optimization looks at shifting energy consumption rather than solely reducing it compared to common EPCs. Using the AmBIENCE results, the 14%, a range of plus or minus 1 or 2 of this estimated saving is foreseen. And if savings are out with this interval, then a reward penalty mechanism applies. And the contract would coincide with the payback period of the measures, so around 10 years. Also mentioned by Lieven, when it comes to M&V, it's very important for any type of EPC contract and also AAPC contract. So it should be performed throughout the duration, where adjustments would need to be made to the models used in the original baseline from AmBIENCE to update the contract as it progresses. So that's in a nutshell the results from the Portuguese pilot, and the key lessons learned relating to the ones I mentioned before. To the first one, client and stakeholder engagement activities, responsibilities between the ESCO, building manager, and maintenance teams need to be clearly stipulated in the contract. And decision-making processes can be streamlined if the potential value and benefits to all stakeholders is clear from the offset. And the second point, developing a thermal model of the Portuguese pilot building is complex, with deep technical understanding required on the ESCO side to define these baselines and performance guarantees, including all the assumptions needed to be in the contract. But simultaneously, these results must be clearly understandable by all stakeholders in the process. And we can see that cost-saving potential from flexibility by just optimizing the operation of some equipment. So the optimization of air handling units and the smart operation of heating and cooling. So that's the Portuguese pilot in a nutshell. I'll pass the word to Lieven to describe the Belgian case. And thanks very much for listening.
Thank you very much, Claire, and thanks a lot for the collaboration. It was really great to work together on, two pilots that were similar to some extent, but quite different in another. So let's go quickly to the Belgian pilot. So the completely different building, a residential building, constructed in 1912, so 110 years old, with only 2 occupants. Quite a big building, as you can see, over 330 square meters. With a ground floor and 2 floors on the main building. But you will see also on the photo on the right side, there is a part that's only 2 floors high and a small annex added. And then on the back side, there's more volume. So today also very low energy class, E. There's windows that are first generation from the 70s, PVC windows, for example. The roof is not insulated. The walls, for the rest, are hardly insulated. There's a flat roof on the back that is insulated, and a small terrace also. But that's about it in terms of insulation. So a lot of brick walls, some double glazing. In terms of lighting, there's quite a lot of LED already, with some CFL lighting left. And in terms of heating, before, when the house was bought in 2012, there was an existing fuel boiler that was replaced in 2016 by a condensing gas boiler. And also in 2012, a wood pellet stove was added. And there's an electrical heater, water heater for sanitary warm water that is still there from before. It's, I think, almost 30 years old or something. So the measures, of course, first of all, we're looking at a deep renovation of the building insulation. You see the ground floor, part of the ground floor plan on the bottom left side, and the volume that you saw on the right side. And then you see, if you look on top, you see some of the volumes in the back. So the main measures were roof insulation using a Sarkin roof, external wall insulation, except on the front facade, which is, of course, highly historical, although not classified. Also floor insulation, and then replacement of windows and doors. That was in terms of the insulation measures, which in itself reduced the energy consumption by 58%. That came also out of the static simulation, and a yearly cost saving of about 31%. Then there are other measures, of course, that were added, adding a heat pump to replace the gas boiler, and also adding an EV charging pole or point for an electrical car. And PV panels on the roofs, on the main roof, on 2 sides, on a part of the wall, and on the back part on a small flat roof. Adding that all together ends up with about 70% cost savings, so quite significant. But you see, there's still electricity being used, of course, for delivering heat, for delivering sanitary hot water. And that's where then the flexibility kicks in to try to improve that. So try to go further. So we did simulations, 8 different cases, from the insulation and adding the PV panels, adding the heat pump, adding the EV charging, and then simulating 3 scenarios for active control. The smart heating, basically optimizing the usage of the heat pump based on the tariffs. Of course, in Belgium, we for that house today, there's only weekend and night and day tariffs. So we were a bit limited there in the potential, but still. And then the other optimization was the smart charging, depending on the usage profile. When can the car be charged? Depending also on the production of the PV panels or the usage of electricity for the rest of the house. So you see on the left side the energy efficiency measures only. So the insulation plus the PV plus the EV charging, okay, that doesn't save anything, but let's say the insulation and the PV and the heat pump. And then you see what the smart heating, the smart charging, and the combination of smart heating and smart charging combined basically delivers. So from the 58%, so you go up to the 70%, you add roughly 12% additional cost savings through the flexibility. That's already a first interesting lesson learned. What we also see is that the smart heating provides roughly 100 euros of additional savings, which is quite limited, of course. But the smart charging delivers almost 3 times that much. That's, of course, also linked to the specifics of the EV charging, because the simulation here was done on a company car, for which the electricity that is being charged locally in the house is recharged to the employer. But the assumptions were quite conservative, so the assumptions were based on charging at the same tariff as public charging. And the existing contract for electricity was a 3-year fixed contract, so the prices were not yet increased. When that contract ends, it's likely that there will be some, well, maybe even a significant increase in electricity prices. But so even with those assumptions, the potential from the smart EV charging was in fact quite important. So some lessons learned. Well, also on the client and stakeholder engagement. First of all, I have to mention that before getting to this pilot, we tried other pilots and buildings. In fact, 3 different attempts were made. First with a university, they stepped out of the project even though they were engaged fairly early on. Then we tried to go through an ESCO who in the early COVID period downsized its business, so that was a dead duck, if you want. And then the third attempt was with another ESCO. We went quite far into discussing with them and with the potential end customer, but there again, the end customer, not so much on the AEPC, but on the EPC as such, couldn't make up his mind quickly enough, and that's why this was basically the 4th attempt, and luckily successful attempt then to get a pilot. But so if it then comes down to finding that pilot, let's say in a more generic way, residential homes are difficult to step into such projects, because today, for ESCOs, it's very difficult to go into that market. There is almost no ESCO market for residential buildings, and certainly not individual homes. So that's a very tough nut to crack in any case. And that could be facilitated by one-stop shops or by more local actors trying to do that and creating some kind of volume. We've also been looking at, in some other project, at cooperative models, for example. Okay, they're all interesting attempts, but it's not as if today we have a clear route to market for ESCOs or for facilitators in that residential market. Okay. If you look at the design process, again, there one of the difficulties was before we were getting to this, the static simulation and then the dynamic simulation using AmBIENCE tool. There was already an energy scan and an energy audit done, which was facilitated by the municipality. The problem is, for example, that they use only theoretical consumptions and comfort, as if the house is being fully heated 20 degrees or 21 degrees during the whole time. But you can imagine, and it's the case, this house is being used modularly. Some parts are not heated at all, or only a few times. There's an artist workshop that's only being used 1 or 2 or 3 times a week. So you cannot draw any conclusions from such an energy audit. And that's already a difficult one because it doesn't facilitate homeowners to engage in investments if they cannot rely on something reliable. So that's where the static and dynamic simulation, of course, also add value, that they give you a real sense of what the savings potential is and the investment and the return on investment for a homeowner. So also the subsidy schemes are not well adapted to this type of renovation, this integral renovation, because the building is situated in Wallonia, in the southern part of Belgium, and you just have to go through different steps that have to be predefined in the audit. We already said the audit doesn't work, so you have to first do the audit, then do the simulation, and then go back, adapt the audit, and then you can get, hopefully, subsidies, and you're never sure that there's enough money from the government either. So that's a difficult one. But if you miss 30 or 40 or 50,000 euros of subsidies in such a project, that can make or break the case. So then there were a lot, and there still are, and many houses of this type will have it, is practical, aesthetical, architectural limitations. As you can imagine, I won't go into details, but even the fact that you're on a pavement and you cannot insulate on the external side, on the front side, and on the inside, aesthetically, it doesn't make sense either. So quite difficult to renovate. And then the interesting part, of course, is that with little investment cost, you can improve, showed the simulations, to about 12% of the annual cost savings, the energy consumption, using the active control on the heating and on the smart charging. And as I said, 3 times more from the smart charging. Good. Thank you.
Thank you, Lieven. Really quite striking to see the potential in the residential sector, which is always the holy grail, I guess. But we know there are obviously many challenges there. Very pleased to have our next speaker, Volker Dagen, come to the stage from Siemens Smart Infrastructure, where he's a vice president. And he's been doing a lot of work there, looking at wider trends as well in the industry. He's an expert in the field with 25 years of experience, and he's also the chairman of EU ESCO, the European Association of Energy Service Companies. The floor is yours, Volker.
Thank you. Is it switched on? Yes, it is. So I was very impressed by the projects you introduced to us, and I'm sure I will more integrate this demand side in energy performance contracts in the future. For me, energy performance contracting is, or I compare it sometimes with Cinderella, because there are few, they understand the full beauty of this concept. There are a lot more, they have no clue and they don't understand anything. And there are few, they try to make it more ugly. I don't know why. So I would like to shine a little bit of light on the go-to-market perspective and on the sales perspective. And if you see, so this we can skip to save some time. The legal frameworks, this is always the thing we complain a lot. So EU does not provide a legal framework for us. This is definitely not true. They did a lot of efforts in the past years. So the framework, from our perspective and from the perspective from a lot of our clients, and we have big clients, industrial clients, they say we are fine with that. The financing models. So we have a lot of financing models out there, and we do not need finance model number 55 or 60. There are not. There are a lot out, and there are enough. And what we also not need is some intermediaries between the financing institution, the client, and the supplier. This was an idea so a couple of years ago that they say we need to introduce all these parties together, and we also want to support them. No, this is a low-margin business. Energy performance contracting is a low-margin business. And everybody who is in this environment wants to earn money at the end of the day. And if we have too many players on this stage, this makes no sense, and at the end leads to less projects on energy performance contracting. So I've listed the usual ones. And what we also need are technical verification bodies. We have them in Germany, and we have some representatives here around, because they are of a great help to make this concept and the contracts on a kind of a neutral basis. Then what we see on the customer side, they don't want to take any risk. Therefore, they refuse to say, oh, no, I will not step in. Emotional things, missing the trust in the business model at all. I mentioned it already. The delay in decision-making. You face sometimes a very huge buying center on the customer side. and a lot of diverse and not interests, not in a consumption. The focus on price, preference for in-house solutions, because the energy engineers in a big company say, we can do this by ourselves. We don't need an external company to do that. We do this for 20 years. The results are whatever. And the selection of inappropriate suppliers. Sometimes it happens that we make the analysis, or the big companies make the analysis, like Honeywell. We have a representative from Honeywell here, or Johnson Controls, and they say, yeah, make us the analysis. And they take these results and go to a smaller company. They offer the same thing for a lower price, which is not possible in the most cases. What we also see are low energy prices. What we have seen are low energy prices. They will come up, and they will be up again in the future. They will be stable. They will be maybe go a little bit lower in 4 or 5 years when the whole story is over. You know what I mean? But and then they will remain on a very high level. Complex administrative procedures, the government procurement rules. This is a nightmare sometimes. In all the member states, it's difficult. And you can come not a step forward if you want to fulfill all these rules. And therefore, also the market on the side of public-owned companies or public buildings is really on going downwards. Complexity of the buying center I already mentioned. So, how did we sell ENPC in the past? We say, okay, doing good. This was the approach 20 years ago. Save money, save energy, be good citizen, be good to the world. This is still valid, no doubt about. But the next step was allocate funds for your core business. This was the sales argument. You say, we take care of your energy. We reduce the consumption of your building, of your facility, of your asset. And we provide this money to you, and you can invest this in your core business. Manufacture some chairs. This is the core business, not saving energy. You should not have anything to do with that. And this was quite a good story. And so today's approach is more sustainability advisory services. So we switch over more to the part of being also a kind of a consultant. Also verified by these neutral agencies, of course. On-site energy supply, integration of that. Battery storage comes up and improves, but it will still the big question mark, how to store electrical energy. You mentioned in your speech at the very beginning, we want to do everything electrical. It's fine if the wind is blowing, if the sun is shining, you know this story. If we are not possible to store this electrical energy somewhere and use it when we really have to use it, and if we really need it, then we are lost. The integration of e-mobility. I'm also active in an association for real estate companies, corporate real estate as well as institutional real estate. And for them, the focus on e-mobility is very, very strong. And they want from us solutions how to integrate e-mobility, because they know this is well coming. Energy and efficiency in building optimization, reduce consumption and OPEX, this is still valid. And now I made it so a little bit in between. What will come up next? The access to actionable information. Companies want to have more information out of the sensors they have in their building. And we have a lot of sensors from light, from heating, from ventilation, from cooling, from each and everything. And we do nothing with this information. The only thing we did was to use it to reduce the energy consumption. But there are so many more information you can make out of it. And this we also sell and provide with maybe an energy performance contract. Energy efficiency as a service I already mentioned. And then the part of ESG, sustainability, EU taxonomy. These will be the new drivers that companies have to step in. So here in Brussels, you usually use this stick and carrot metaphor. I call it whip and wallet. Because the whip, this is, you have to do it, because the regulator says you have to do it, and the wallet is, can you make some money out of it in a way, or can you develop some new business models out of it, and then the bell in the head starts ringing at the customer side, and they say, okay, then I step in. Operational reliability, especially for industry companies, a huge point. If you are in the process industry, for instance, chemical or pharmaceutical industry or steel industry, it's a nightmare to have no operational reliability, because if a process is ongoing, you cannot stop it and say, okay, the wind is not blowing, the sun is not shining, I have to stop my converter now and start it later again. You have destroyed millions in half an hour and less. Battery storage I mentioned, so we come and compare this. These are the new sales approaches we try to use to make it more attractive. So what are the outlooks and recommendations? One of the questions was market figures. We don't have any good market figures. The best market figures have our friends from the Joint Research Center. And the publication is online. They disseminate it every 2 years, as far as I know. This is the best basis you can have. Then all technology is available. Since years, since decades, this technology is available. We have to implement it. We don't not to invent something new. We just have to put it in place. And then I make a big question mark behind these insulation materials. Not because I'm from the building industry. I would be happy if we could find some insulations material. They are not based on petroleum or crude oil. Because this is not of a help. This is not really of a help. Take rock wool, for instance, if this is possible. I'm not an expert on that, but this cannot be the future. To put some oil on the walls of buildings, and in case of a fire, we had this example in London a couple years ago, where a high-rise building was burning over days because of this insulation material outside. And what do we do if we want to dismantle these buildings? We have no recycling capacities. And we talk about circular economy. Not a good idea. Anyway, well-trained engineers, we already had this point, so Jesse mentioned it already. We need some people to install this. We need some engineers. We need some technicians. We need some engineers to do the prerequisites and all these kind of things. This is a real bottleneck, and we don't come any step forward. We try to hire some people on this field, and we don't find anybody. We don't find anybody on the market. Then a very simple thing: we need a good internet connection. Sounds very normal and not of an instance, but This is not given at all the sites we already approached. Simply than that. And if we say we want to do some monitoring of the equipment installed, and we want to do some service, and we have to bear in mind we have a low margin business, then we have to do it via the internet. And if you have not a proper internet connection, it is not possible. Yes, of course, EPC has to go in hand with decarbonization. The market is fragmented in small projects. We all know that. The rising cost of energy and operations, this will become a game changer, definitely. We had this so 10, 12 years ago already, where the oil prices raised. I don't know really why. And in these years, so 2008 to 2010, we had a lot more projects than we have today. And for a client, just to bear in mind, select a provider that really can guarantee the savings and can step in a shortfall if they don't achieve them. I saw in the presentation of our colleague from Italy, there were 1,200, I don't know how many ESCOs. I doubt that these ESCOs are really able to fulfill their guarantees. Because these are small companies. They have 5 people, 8 people, 10 people. They have to install, they have to be out on the customer project, on different customer projects. They have not the time to analyze on the screen or on premises what's wrong with the installation. They have definitely no time. They install it and go away. And you as a client, you are alone with it. And therefore have a single point of accountability. If you make a kind of a consortium of small and medium companies, this is fine, and we also support this. A lot of our projects we don't do alone as a big company. We have a lot of subcontractors here, small and medium companies. But we stand there and say we are the general contractor, and if there are problems, approach us. Don't go, in Germany we say from Pontius to Pilatus, from this to that, and you will be disseminated around, and nobody is responsible. Do it with a contractor who can take this. And then I'm over. Thank you.
Stay on the stage if you like. We'll have a panel discussion now. So if we would like, actually, sorry, Claire, we have, let's see, who is on the panel today? Lieven, Claire, Volker. Is Gregory in the audience? Chris as well, please. Oh, Gregory. Good to meet you. Welcome. Please have a seat. Anywhere you like. Maybe I'll stay at the edge there, though. This one, oh, doesn't matter. So I'll go here. Oh, it's fine. Great. So I've got the screen here from the audience as well. So please, online audience members, do feel free to ask questions. You're more than welcome to submit questions through the online tool. We receive those here on the screen, so we can ask the speakers to respond to those. Let's see. So before we get started, you all know Volker, Lieven, and Claire already. We have on the screen as well Sofia Tavares from EDP, Portugal as well. So what I'd like to do just briefly before we start, so just introduce the other speakers who you haven't met. So Sofia is a director at EDP, the Portuguese utility, and she has been previously responsible for the business unit for energy services, and she's now doing more marketing across Europe, but she's got quite a bit of experience in the field, including previously from the Portuguese energy agency ADEN. To my left is Chris Karts, who's also from Vito, much like Anik, and he runs a variety of positions there, and he's a research activity leader. He knows a lot about the project, about AmBIENCE, and he can tell us much more about the technical aspects as well of the project. Then finally, we have Gregory Tilte from the Smart Buildings Business Unit of AmBIENCE in Belgium, where he's Division Manager for Sales and Smart Solutions. He's worked in the energy sector in various roles for quite some time. Previous experience, interestingly, in investment, M&A, and financial services. So his insights are going to be very welcome today as well. So what I thought I would do, there are 6 of you. I thought I would give each one of you just a brief chance as well to say a few words of hello, to introduce yourselves, especially for those who haven't said anything yet this morning. We'll start with Sophia in a moment. But I also want to ask each one of you a bit of a question or a challenge, if I can try to frame that a bit. So we know we've discussed a lot of topics this morning around active energy performance contracting. I guess in a nutshell, I would say you have the perspective of the energy system and the grid and the regulatory environment. That's very important here. We have a kind of intermediary space of aggregators, of facilitators, energy agencies that can help make this market work. And we have the level of the building itself, where the savings take place, where the flexibility services can come from. In your opening comments or your discussion here today, could you tell us, from your perspective, if you had to pick one of those, the big picture, the regulatory framework, the energy system, the intermediary space, or the building level, which do you think is the most important starting point to get this market rolling? If you had to put your money on one bet, where would you start? At the building level, at the grid level, or in the intermediary space? If that's hopefully a clear question. And I'll start with Sophia, if you can hear me okay. And we'd like to hear from you, please. Thank you.
Good morning. Can you hear me well?
Morning, yes, we can hear you okay.
Okay, thank you. First of all, thank you for the invitation. It's a pleasure to be here with you. I'm sorry I'm not physically there with you, but it was not possible. Regarding your question, so I would pick the customer, the building complexity, not only about the building as a whole in terms of equipment and systems, but the stakeholders. So it's something that, from my experience, it's the thing that makes this more complex, or the market is the adoption of this kind of contracts, or even energy efficiency measures, or active flexibility on demand response. I think this is the main reason why here in this sector things are going slowly, even though we have a lot of potential.
Thank you for that. So definitely the building level, the customer level first. Perhaps I'll go from left to right here along the panel. So Chris, if I may hand over to yourself.
Yeah, we also think the building level is a very important part, because the starting point of the project was basically the observation that we don't think we're going to reach the targets by just focusing on efficiency. Specifically not focusing on just deep renovations, because it's very expensive, takes a lot of time, we don't have the labor force. And we took the position like, well, we should kind of renovate to electrify. That was kind of the bottom line. How can we renovate as much as possible buildings to a level that you can electrify? Because with the electrification, you get immediately a big slash in the emissions by the higher efficiency, by the, the better carbon intensity of electricity. And that's kind of, I think, a very important observation that we had. And from there, of course, to demand response, because once you are electrified, you also have, and in future, you will have more, interesting business cases related to demand response, so related to active control. And also, the electricity itself will become greener and greener every year. Yeah? So once you have surpassed this kind of first barrier of having electrified your building, you will get like a smooth trajectory to increasing benefits, improving emissions. And of course, after that first, renovation step, you can later invest still more in further improving your efficiency. But we really think we must go to a kind of two-phase approach there.
Thank you. Perhaps a hand over to...
Yeah, I'm not sure if my answer fits in any of the categories you mentioned, but anyway, okay. I'll try. I think what we have to do is move from the project level to the program level. And that means, as we have been trying to do, and to some extent successfully, I think, with the classical energy performance contracting, is increase the volume on the demand side with the building owners. And we've done some work recently on the notion of EPC or AEPC project aggregators that aggregate demand. And if we manage to aggregate demand and make bigger volume, I think then the ESCOs will start using it automatically. Because they are already capable of aggregating supply in the sense that they can cluster buildings today, do EPC project with 10 or 50 or even 100 buildings. That's not such a problem for them. I think also the technological barriers, there are some, but they can be overcome. But the lack is we don't have enough people putting projects into the market for AEPC, I think. And if we can solve that, move it from a project, make programs, and who is best placed? It's very large building stock owners or one-stop shops that represent building owners and today already put EPCs into the market with a large volume. If you can get them to put AEPC projects into the market, then I think we have a good potential. So that would be my focus. Focus on programs and aggregation on the demand side.
Thank you, David.
Thank you. Yeah, I think across all three levels, it will push forward at the AEPC contract. I agree with Sophia at the building level. It's definitely, that's where the client, if they understand the benefits of this kind of project, then it's going to drive the process a lot quicker, a lot more streamlined, and the complexity of the different stakeholders at the building, if they're all on board with how this concept can benefit them, then that's going to drive forward the process. And that maybe comes from the top level. So you have this push from new regulations, the push for net zero, the emissions trading scheme initiatives that people have spoke about. So the kind of top-down initiatives drives the client at the building level to push for this net zero. And therefore, the middle section will need to be galvanized to provide that service. So, yeah, I think they're all interlinked, but I agree with Sophia that, yeah, the building level is probably the most important.
So you'd hedge your bets across all three.
Yeah.
Over to you, Gregory.
If I try to take a step back, maybe from your question and drill down to it, is if the global goal is sustainability and energy savings, clearly the active component can play a role. Many sources, and we should not restrict ourselves to EPC to do it. And I think in the market there are already some places for large industrials where the active component is already a reality today. But drilling down gradually to the different topics and EPC and active EPC or active buildings, well, the technical aggregation layer, so at the building layer, making sure we extract, we model the smallest granularity of the flexibility we have in the buildings. For sure, deeper renovation, electrification will generate more displaceable loads, for sure, or sources of production. But there's already a lot. When we look at all the cooling groups, when we look at existing heat pumps, when we look at other elements like lighting, there are still possibilities to shift it. So what I would say is clearly building, but let's start already. And even if we dream for large programs and projects to get the bigger volume, nothing prevents us from starting already, and it ends with the different stakeholders.
Thank you. So, despite what we all have discussed today and all the possibilities we have to build up sources for renewable energy, I would invest most of what I had in education. Because the next generation, these are the people, they facing the real truth. Not we. Not we. We all disappear more or less. But the kids, they are 2 or 5, they have to save energy. And I would educate them in all the possibilities not to use energy or to use less energy than we use today, supporting by all the technologies we already have. But they have to build up the conscience to say, okay, where can we save energy? Where should we not mess around with what we already do? Thank you.
Actually, Volker, if we stay on you for just a moment, I just wanted to pick up on something, and it's a question now to all of you as well. You mentioned the role of intermediaries and the low margin nature of the EPC business. At the same time, there's a thought in my head around the volume of public money that, you know, the Commission colleague spoke this morning about the billions of euros available in the next funding period for energy efficiency. Do you think this might be a good way to actually use that public money, to have free intermediaries provided through public money who can help the projects along without impacting the business case?
Yes, of course. We use all the help we can get. Yeah. But to get the money, to get public money, this is not that easy as it looks like. These European investment banks say, okay, we have these millions and billions of money available, and the Green Deal says we have hundreds of millions available. But to reach this money, to lose it, to release it, this is the big question. And therefore, these processes, they are so complex that a lot of people say, okay, I have tried it, but I really gave up after a certain period. If this could be more easier to access, to address and to access, this would be of a great help.
Yeah, I think, and I'd welcome comments from the other panelists as well on this. And I know, Lieven, you mentioned that, you know, subsidy schemes are not that well suited for deeper innovation. So there's a huge opportunity for money coming you know, down the pipeline. How can we best use that money? What are some mechanisms we can use to?
I'm not saying that necessarily that the subsidies aren't there. I think they are difficult to obtain, and that relates a little bit to what Volker was saying on a higher level at the EU level. But I think they're not necessarily adapted. For example, one of the things in the sector we've been talking a lot about, but nothing has really happened, is maybe to start subsidizing performance rather than technology. And I'm talking about innovative technology that needs to be supported, but there's still a lot of projects where you subsidize and then in the end the savings aren't there. So maybe we could at least reserve some part of the subsidies where we subsidize performance, guaranteed and measured performance. That could be already an alternative way to make those subsidies, for example, more efficient, I think. But somehow it doesn't seem to get to the people who are designing those subsidies.
Yeah. Any other thoughts from colleagues on this topic of public money and subsidies?
Yeah, I agree that it's not easy to obtain the money, as Volker said. So for sure, that process must be simplified and much more accessible. Next to that, I think the idea that you phrased like, well, maybe some part of the money should be used to have like free services facilitator like that are able to do scans and select the markets and select the building stock and identify the quick wins, identify which specific building typologies or building owners could be accessed, and convince them that with a relatively low amount of money, they can really achieve big savings in emissions specifically. I think it's twofold. It's the process. It's also, I think, speeding up the process of tagging buildings on, okay, we should focus on this, yeah.
Okay.
And have it not like a random process, and it's just the initiative of the building owner that says, well, maybe I want to do something. Yeah. A more proactive approach where somebody can approach them, I think would maybe be beneficial.
Claire, I think you had a comment here.
Yeah, just on the access to funding. So, well, we mainly focus on the Horizon 2020 and EU funds for innovation. But through these projects, usually there's an element of knowledge transfer between the projects. And I think that part can be quite important to communicate these other types of funding that are available across Europe to the different countries across Europe. We had some examples of public lighting projects, energy efficiency projects that were funded by a European Investment Bank. And through the knowledge transfer and sharing throughout these innovation projects. Different countries can have more access to that knowledge on how they can apply for these funds and how it could work in their local context. So.